Welcome to Hubble's Universe Unfiltered. I'm Dr. Frank Summers of the Space Telescope Science Institute. Our moon is very special. It is Earth's companion in space, and it is, one of the brightest objects in our sky. The sun, of course, being the brightest object in our sky, but the moon is the brightest object in the night sky. Now, you may not know, but our moon is rather special because it is very large in compared to the size of Earth. For most planets, the size of their moons is very, very small compared to the size of the planet. For Earth, the moon is about 1/4 the size of Earth. And having such a large moon allows us to see some pretty spectacular things. For example, sometimes the moon actually passes in front of the sun, and due to an amazing cosmic coincidence, it can actually cover the entire sun. And we can see not the sun, but the solar corona around the sun. And as I said, this is an amazing coincidence, the fact that the moon happens to be the same angular size in the sky as the sun. And let me just note that that won't stay true forever. The moon is slowly moving away from Earth, and so eventually there will come a day when we can no longer get total solar eclipses. The moon will be too small in the sky to cover the sun fully. But that's not going to happen for millions or billions of years, so you don't need to worry about that. We will still see total solar eclipses during our lifetimes. Now, the moon can also not just block out the sun, but it can also block out other objects. Now, here is an image of the moon. You can see one of the mare on the moon. But there's this funny thing going on over here, and let me blow that up. And what is this? This is the planet Saturn going behind the moon. Now, we don't call this an eclipse. We actually call this an occultation. Okay? When the moon moves in front of Saturn, we say that the moon occults Saturn. And this occurs every few years, relatively often enough to get some really good pictures of it. And you can see it's really kind of fun to be able to see a really close image of the moon and see Saturn right there. Now, our moon is one of 7 large moons in the solar system. We only have 1 moon, but imagine Jupiter. Jupiter has 4 of the 7 large moons. Earth has 1, Neptune has 1, Saturn has 1, but Jupiter has 4. And these are the 4 Galilean moons discovered by Galileo 4 centuries ago. They are Io, Europa, Ganymede, and Callisto, shown here to scale with Jupiter's great red spot. So you can see they're pretty large. But again, they're relatively small compared to the size of their planet. Still, it gives you plenty of opportunities to see interactions between the moon and the planet Jupiter. For example, this is a Hubble image we obtained of the moon Io passing in front of Jupiter, and this black spot here isn't a storm like the great red spot. Instead, it's the shadow of Io moving across Jupiter. If you were here on Jupiter, you would see an eclipse of the sun due to the moon Io. Matter of fact, we got even greater than that in this image. Now, hold on, let me pause for a second here. This is not a visible light image of Jupiter, okay? Jupiter doesn't all of a sudden go pink and green and blue and in all these psychedelic colors. What we're seeing here is an infrared image of Jupiter. Okay, we took several band passes in the infrared, and then we translated those to visible light colors in order to be able to show them to you, because, what does infrared look like? Your eyes can't see it. So we translated those colors to the visible light spectrum, and we ended up with these really funky colors. All right, they don't really mean anything except if you were trying to translate them into the infrared emission. But we're not really too worried about the infrared emission. What we're interested in looking at are these black spots here, here, and here. We've got a movie to show you that goes in and looks at them a little bit more closely. So if we zoom in, you can see the planet Io is casting this shadow. And we pull back and the moon Ganymede is casting that shadow. And this shadow here is due to the moon Callisto, which is actually off the edge of this image. So we captured a triple eclipse on Jupiter. Kind of cool. With the large moons, there are 3 eclipses happening at the same time. Now, I suppose you could possibly get a quadruple eclipse, but we haven't been able to get it. We should probably calculate when the next one of those is going to happen. And if Hubble's available, I'm sure Hubble will get an image of it. Now, just like we can see eclipses as well as occultations with our moon, we can also see eclipses and occultations with Jupiter. This is an image we recently released of the planet Jupiter occulting the moon Ganymede. Let me blow it up a little bit so you can see it a little bit more clearly. Here is the limb of Jupiter, and here is the moon Ganymede passing behind it. And when you compare the radius of this circle and the radius of this circle, you can see that Ganymede is much, much, much smaller than Jupiter. It's nowhere near 1/4 the size of its planet, like Earth's moon is to Earth. And so we see Ganymede slowly passing behind Jupiter. We actually got a series of these images, and here they are. And these images aren't all taken in the visible light. Matter of fact, these images over here and this image here, these are taken in ultraviolet light. These were taken in visible light, and these were taken in visible light, and this center one here was taken in infrared light. The purpose of doing multiple band passes is to see how Jupiter looks in the various wavelengths and to try and understand the depths of these storms. I mean, if you look really carefully in at some of these storms, you can see they actually change markedly as you look from band pass to band pass. And so you start to understand different things about the storms. But let me just say, let me give a mea culpa here. I'm not truly interested in all these details, because this is a really beautiful sequence. I mean, it reminds me of the Earthrise sequence from the moon, as you can see Ganymede slowly descending below the horizon. I really was attracted to this simply for its poetic value, and the poetic value of watching Ganymede being occulted by Jupiter. And there, the moon slowly passes in behind the planet Jupiter. It's very beautiful and rather poetic, I think. Kind of magical. But I'm a geek. I have to destroy the magic every now and then. This isn't truly a movie, okay? Because Hubble, first of all, doesn't take hundreds of pictures. In order to create a movie, you need hundreds of frames. I just showed you the images Hubble took, that and a few more. So there may be 10, 20 different images that Hubble took. And to create a movie like this, you need hundreds of images. So what they had to do was interpolate the frames in between the Hubble images. Furthermore, I just showed you that they observed in many different band passes. And you didn't see the surface of Jupiter change during that movie. So they had to then take a common Jupiter, bring Jupiter to a common view from the various band passes as they did this movie. Now, I hope that doesn't destroy the magic for you, because it's still a beautiful movie, but I just wanted to let you know that it's not what Hubble sees. We don't have Hubble up there as a movie camera, we have it up there as a scientific instrument, but if you work hard enough with it, you can create great poetry. And to me, this sort of reminded me of the children's book I've read many times to my kids, Goodnight, Moon. And so we labeled this episode Goodnight, Moon. And let me just sign off by saying good night to Ganymede. Take care, and we'll see you next time.